Hello. No, it's anonymous to you guys, not to me. Right, you guys couldn't see the other people's answers, but I could see them. I was just checking to see if the numbers were still about what I was. But it doesn't matter. So I can see those of you who picked more than 3 and broke the rules. That's the fact. It helps. So what I do with this, and I might even just like delete it all and then we'll redo it maybe for a few days, just as we're kind of refining stuff. What I'm going to do today is I pick, let's say, the top 3 or so, and then I kind of design some weird little things that we're going to walk through. So it's not exactly what's in the tutorials, it's us doing something else. Makes it a little more beneficial, and I'm not just saying like a video. Nuts. And so we can work through some problems and some other things. So now I did notice that the way the numbers worked out, let's say divided line surface, pattern base, those 2 are the top. Generic model into an adaptive assembly. That's the one where I make that truss and there's that wood clip, that goes into the truss. That is a little different thought process. I'm not going to do that one today, even though it's one of the ones rank type. We'll do that in another day, just because it's just I want to make sure that's very clear and that we're actually into it a little bit before we do that, because there's a little fussiness to it. I know you weren't able to watch all of them in this time frame. I think when I did this class last time, I probably didn't even put this out until the beginning of the 2nd week. But I end up just walking. That's because the videos that I post to YouTube were other older versions that weren't as clear and didn't walk through some of the basic stuff. So because that was out there, I was hoping you watch that more and I don't have to do those basic tutorials. We will kind of embed them into this a little bit though. I think I lost my other pair of sunglasses here last week. So that's my dollar sunglasses. All right. What's the initial frustrations you have with using Revit? You love it? It's so wonderful. What are some things that, because with you guys all have the same problems. I mean, we will all fall into the same little thing. So what are some of the problems that frustrations that you find you have? No, you shouldn't have to do that. No, you shouldn't have to do that more than once. So we'll look at, see where because it's, yeah. What's interesting is you could, yeah. In any of these, you can actually type in, even if you're in a different units, you can type in the unit you want. Like if it's set to metric and I put in 6 inches, it'll go 6 inches. Like it knows the conversion. So, but that's interesting. I haven't had that problem. You can set up in the projects, you can set up a template that then controls that specifically. But are you converting like a generic model into? Oh yeah, but when you do file new, let's say file new, family. The family templates there are two different, like I have it automatically going to Imperial Library versus Metric Library. There's two, you know, I think there's an entire like catalog already set up that way. I think that's how it works. Not positive. Projects, I see it. I haven't some of that there, but we can look at that. Anybody else, like just things that you run into? Yeah. I was playing around with doing something like a bicycle spoke. I've got some markers in here somewhere. And I'm going to tell you, before I do anything in Revit, I start to sketch it out. I was like, man, I got a whole bunch of markers in here somewhere. All right. So first thing I did is when I was thinking through this, I was like, look, I want to make a bicycle spoke of some type. So I'm going to have a line, which is going to be the hub, right? And I'm going to have like a center point somewhere on that line. And then I know, there's going to be a diameter of the circle that's going around that. I also know that the hub of a bicycle is usually the hub is actually thicker than the rim, right? So this might be the rim around there. I'm going to want a smaller circle here and a smaller circle here. So I'm already just kind of visualizing that for myself. How do I want to control this? Now, this is where we really get the difference of who has played with Grasshopper? A few of you. I mean, just looked at it in some ways. Fundamentally, everything we do with what we're doing here, especially the what we call reference lines and adaptive points, we're in essence just graphically creating a Grasshopper script. Okay, that's just all that's happening here. But so the same way, I was taught Grasshopper from Jenny Saban, amazing person. She was one of kind of the founding people that kind of did a lot of parametric work with Grasshopper and creating it. Took a class from her, and it was just like, go learn it. I was like, this is terrible. But the key thing that she did is she made us actually like write out what we wanted to do. I want to make a line. I want to find the midpoint of that line. I want to, and just by writing it out first, we understood the logic that we're controlling this thing by. And sometimes you had to go, well, I want something that does something. You had to break, well, what is this? What are the elements and how am I controlling them? That is fundamental. Okay, you have to do that. This isn't just pushing a form around. Okay, which also means why you kind of want a good idea where you're just sketching it to figure out what are the parameters, what are the variables that you want to mess with. If you try to just get in there and sculpt and move stuff around, you're going to go nuts because there's 18 ways to do stuff and you don't know what that path is going to get to. Okay, so knowing what your variables, what you want them to be, it doesn't matter what scale it is. I know what parameters I'm going to set. Okay, so let's say I want to make one of these things. We're going to start by doing this. I'm going to close this one down. I will just do it to file new one. So I'm going to just go file new family. Now, for those of you, you're like, what? Mine goes to a perfect little spot that yours doesn't probably go to, right? If you go file new family, you probably get this whole structure of different countries listed and go into and units, right? What I did is I traced back. I went, hey, I don't like dealing with that. So I had this open, I traced back where it was, I went into this file folder and I deleted everything else and re-put this right where it looks. That way I didn't have to deal with any of the rest, and every time I hit it, it opens right there. So I made it easier for myself, because since you open it, I don't know, like 18 times every time you do this, I wanted to save that time, right? Nothing more than just going in and deleting those files in that program manager. That's how I found it, okay? So if you just open that up and hit G, let me do it again. Being fast, like file new, family. I hit G, and automatically goes to generic model adaptive, because that's the first one in the list. And I can hit enter. I don't even need to scroll through. Yes. So that's what I mean. Like I deleted all that structure first, so that if you go into, that's what I mean. Like so this was just one thing. I went into the real. I went into, I had these both set up. I had this set up over here. I had this set up over here and said file, new, family. So, okay, where is this located? I looked at it here and then I went into my actual computer and I changed, go away. I went through and I changed the file structure by going into my C drive, program files, whatever, delete that. So otherwise you got to go in through US and all that stuff. Where's my mouse? I'm so bummed. I got to use a crappy mouse. That's my real mouse is not. Oh, bummer. My favorite mouse is kind of dying. It's either that or the USB port's dying. I can't tell. It seems to be having more trouble. You? Let's see. Yeah, this one's pretty smooth. So that is a way to get that to work. So so we're in a generic model adaptive. We're going to create stuff that the orientation is actually completely arbitrary here. And a really important thing is just making sure that we're snapping to an object or a line or to the point or whatever we're doing. So for this, I drew a line, which means I want to move this line around. I probably want 2 adaptive points would be one way to think through this. One adaptive point there, an adaptive point here. And then this is the way I built the first one. So I can stretch it and put it wherever I want like this. But there was a couple of you picked the box that goes up and down in the topography or the drawer, the elevator, the drawer. I talk about it like that way. Like 7 and 8, tutorial 7 and 8, where I have the topography that I cut with the advanced divided surface, right? And I'm kind of moving stuff around in a kind of a controlled way. I kind of pulled that in a little bit. And so my first way was the one I'm going to show here. I did by making 2 points, okay? And I created it on a line and I could move that around and it'll go away. And it'll adapt to it. But we're going to do this one a little bit differently. This would be like the easiest way. I want to snap it between 2 things and have it point somewhere. That might be really useful. But I was realizing, well, maybe this is like an umbrella or like a pillar structure or canopy. And a lot of times we want those verticals to always be straight. Okay. And so I was like, oh, I want another constraint on this. Okay. So instead of, let's say I drew this out first, it's like, no, wait, I always want that to be vertical. I got that center point again. A point above it, a point below. I've got a circle happening, and a circle happening, and then a big circle happening, right? I'm going to have spokes going out. So now all of a sudden, I really just have 1 point here that's important to me because I want that always vertical. So we're going to do a little trick here because that's important to me. But I also want to control maybe where the height is of this in a unique way. Maybe I want it to always change the height, right? So I'm actually going to put another point out here and say wherever this point is in space is where this will be in height, which means we can place it, we can move this point around, and they'll all move with it. Okay, so it's a way of having a little more control later. This is a lot like how I did the box that races up and down in the topography in 7 and 8. So I want to have a ring of structure that I can move up and down like this. This idea of type versus instance. Okay, that is a really important thing to go through here. Type is like, I want this door to be 6 foot, 8 foot, 10 foot. I'm going to tell it that type, and that's what it'll be. Okay, that's great. I want a 2-inch diameter, 4-inch diameter, and I can just change it, and they all become that. If it's an instance adaptive thing, it means every one of them might change. Okay, so when we go that, you just got to be aware because you want something to change every time. Well, do you want to make a type for each one of those, or do you just want an instance one to always adapt to it? Those are 2 things. You can change something on the way, but that's what we're going to work through. Okay, so the goal is to make this to begin with and have it function. Sorry, Rachel, the drawings are on the wall, but I can't do both at the same time. So in essence, you're just seeing it this way. So with this, I'm going to start by putting the point down. Sweep and grab. I do a lot of sweep and grab in Revit. Okay. whenever I'm watching you guys, this is not about being exact in almost any way. Like, you're not about trying to pick the perfect spot. It's always just about sweeping, grabbing, and telling it where to go or telling it to align. But a lot of it's like throw the wall in there and then tell it where to be. Like, it's just a different way of working than you're used to, which also means you don't have to work as accurately because you're just telling it where to go. It's a very different mindset. It's actually much faster once you get good at it. So sweep and grab, adaptive. Now I'm going to set another point, and this is where SW, and I'm grabbing that horizontal one, setting it on there, escape. I can grab it, and I can pull it. Oh, come on. All right. I can grab it, and as soon as I know that I'm on that one, it says offset 0. I can just write, let's say, 4 feet. Okay, does this make sense? That I made sure it was on that one, hosted right there. Okay. If you've just opened up this program and not opened anything, sometimes the 3D snap's not hit. You have to hit 3D snap the first time. It happened, I already had files open, so the 3D snap had been hit, so then it stayed open. That will be something you'll stumble upon. This is why you working next to someone else physically working at the same time is super helpful when you're both doing the same thing, because you realize what silly little thing you just tripped up on. Okay, sitting at home alone is not the way you're going to do this quickly. I did it, and it took a couple summers, and I'm really good. I mean, I'm good at learning it, and it still took me a long time to get good at it. Watching bad videos. So this concept that no matter where I put this thing, that point is hosted above it, right? So now I think, okay, what to me is the maximum that this umbrella might go? 100 feet. I don't think, in my design, I really don't think I'm probably going to go over 100 feet in this project. I'm going to put this at 100 feet. That makes sense, way up there. Now I'm going to go reference line from that point. This is where the 3D snap is really important, because it'll look, if that 3D snap's not on, it'll look like you snapped to it, but you didn't. You'll orbit around, you realize it didn't, or it moves, and all of a sudden the line stays there and the other stuff moves, right? So this is the whole thing, is this idea of hosting, one thing's telling the next thing what to do is important. So snap there, escape again. This idea of flexing, make sure it all moves. I'm going to put another point. Yep. So the very first time the SW comes in when I was placing that first point on this one. So like right now, because this is the plane that's normally just being set to, right? So when I wanted to do this one, I clicked it, SW, I can put that point and then hit it. And I grabbed it and told it 100 feet above. We do this all the time. Now it is hosted on that, right? Reference line from here to there. Escape, escape. Again, I'm always just moving it to make sure it works. There's nothing about been working like 2 hours on something and realize one of the fundamental ones wasn't actually attached to it, and then all the logic isn't there. So the flexing or just moving it once to make sure it all moves is what you need to do. Okay. Now, this is another thing we do all the time. I'm just going to put a point on here anywhere. Okay. Actually, I know I need 3 points, right? I know I want 3 points, 1, 2, and 3, right? Okay. I'm also going to, I'm just for my own sanity, I'm going to put another point right here, but all of a sudden I'm going to grab that one and say, I need to make that adaptive also. I'm raising it up a bit. Okay. So it's just, I know it's a little higher. A lot of these things, even with the very first pipe one, I want to do one thing real quick. This happens a lot. You're not paying attention. And you do that. You think you're on the line, but look at the size of the dot. It's very different. So you can always tell if you've actually posted the point on the line or not based on its size. You get really quick at that because sometimes it looks like you're on it and you think you are, and then you realize it's not controlling it that way. So just the size lets you know. So those are like 3 different dots, like adaptive point, normal just point floating out doing nothing, and then one that's hosted on something else. So it's smaller because it's being controlled by something else, right? So this idea of the parameters, we're going to grab this bottom one down here, and we can already see that it says normalized curve on the left. So it's just saying what percentage is it along that line, right? Does that make sense? So we can control this in the pipe. A lot of times we make that to segment length or something, and then set X number of inches. We could say, you know, there's all these different ways. Chord length, it's based on it being 100. There's a lot of different ways to control that. But another way to control that, which is awesome, this is insane. Like this function can get really nuts with stuff when you can think through this. I did a spiral staircase just based on a whole bunch of points on a line, and then you can make the curve whatever you want, and you'll get the perfect rise on it. It's this. So I just grabbed that point, and I said I want it to be host point by intersection. As soon as I grab that, I can grab that plane. Whoop. So it's making that point wherever that horizontal plane of this. That's nuts, right? Now it's funny. I hadn't done this because I did it the other way there. This will be interesting. This is gonna be I haven't done this before. This will be new. I mean, I've done this part. I haven't done what I'm going to do next. Those two. That's interesting. Let's see. I haven't done this. I've always made it by distance. And so then the distance was, I would say, up, down. I'm going to show you some really quick. The way I did this in this one, go away. I don't care. Go away. The way I did it in this one was I made a parameter for what would be the center point, and then I went up a few inches and down a few inches based on something. So that way I had those 2 points bracketed by wherever that one was. That's a dimension. Here, let's see what happens. I go SW, aha, I can. So now I'm setting that point based on that one. And I'm going to tell it, we're going to make this parameter, and we're going to say new parameter, hub. We'll actually define them each. Hub up. Okay. Okay. And we're going to say hub up is, let's say 6 inches. Should probably go a little more than that. So let's make sure that moves. This is what I hadn't done before. Yeah, somehow it breaks that. Can't do it that way. Interesting. As soon as that controlled that. I should have done something new. Always doing something. There we go. No, so as soon as I told it to host something else, it gave up on that. All right. By breaking it, you'll find that redoing something is a hell of a lot faster than trying to make something work. That's working. I'm going to do the same thing, SW, but put another point up here. I've already made it up, right? I'm going to make it a little bit more just so I can see it. Let's say 4 feet. All right, now should be able to put another point over here. Grab that one. Host by intersection. Oh, come on. Won't give it to me. All right, there's another way we can do this. Trying to be fancy. We're going to draw the major radius on here, and then we're going to draw the middle hub and make it an extension, and it'll work. So we want to draw a circle on this point, right? So SW, And I'm drawing it whatever size I want right now. Just by drawing that line, it's a real line right now. A line versus a reference line. A line is like an actual object that you would see. It would be a line that's drawn in the drawing. And in essence, it exists as a thing. A reference line is something that, of course, you can pull and tag to. So you can change it just by telling it to be one or by starting and telling it to be one. Now I want to control that dimension. By clicking this little thing, you make that dimension real. When I have that dimension selected, I can then control that dimension. And I'm going to say I want this to be a diameter. So now all of a sudden I can come in and say I want that diameter to be, let's say, 12 feet. Okay. So that process of throwing something in there, telling it how you want to control it, and then labeling it is kind of just the process that is a quick way of getting through this, right? So the other way to make, I'm so bummed I can't do that the other way. I wish that other intersection. I wonder if I want to make sure. Oh, you know what? This might work. So you can tell a point to always be seen. See what I did there? It's still not a it's the adapt. This is an adaptive point. When you grab it, it says it's adaptive. All I did was I told this point I want the reference lines to always be seen, and that might give me the ability to host by intersection. Yep. All right. I'm way around it. Yay. That makes sense. I just kind of did something weird. So. And I always find out what, so when I hosted this point on that one, it then messed up its logic. Somebody didn't like that. But that adaptive point, you can put tons of stuff on adaptive point. It understands that it's like controlling the world, or at least a part of it. So I'm going to do another SW on that plane here, and I'm going to go down. Another parameter, up, down. There's lots of ways of thinking through this. I could have made one dimension and then said positive and negative. I'm just going to make this equal -4. Again, I got to take this one. This is this fancy little thing of just saying, it says show reference point never when selected or always. That allowed me to save this. It's funny, I worked through those other things last night. I was like, this morning I was like, oh, it'd be way cooler if I do it to where we do this. But I hadn't done it, so really. All right. Now we got. So again, I can do reference circle SW, that one. I don't even care. SW, that one. Don't care. I'm not changing the dimension. I'm making the dimension real. I'm grabbing the dimension and saying I want to make it a parameter. All right. And I'm going to grab this one. What's nice, I just make it. I grab that. I want it to be the same. It's already made, so I can just say hub diameter goes to the same thing. Right? Come in here, the hub diameter, let's say 1 foot. All right. Now we got our 3 things. They should all move. Having to pick these differently is going to be annoying, but still crazy. It's working for us. Nice function. I'm going to grab this one, and this one. And this is the divide line. Okay, divide line is super nice as they're still selected. I'm going to make the number that it's divided its own parameter. So they're all being controlled, right? Let's say spokes. Okay. The nice thing about this is I can now grab it and say, I want the spokes to be 12, and they all change. It's really, when we do this next step of repeating, if they're not on the same one, you change the number, you got to redo it every time. So it's just, if you have multiple divided lines, having them be on the same control thing, like that step, you can control them individually, but then you got to replace the thing every time. So it just gets a little annoying. So now I have a pipe made. So I'm going to go in LF, load family. I have my generic pipes. There's my basic pipe. And I made my basic pipe a structural component. So there it is. I'm going to double click into this. And I'm going to say rename, and I'm going to name it cable. It's important to take a second. Now, I had an end extension. I don't want an end extension. I wanted that 0. And offset, we're going to leave the offset at 2 feet. Watching that very first video, making this pipe, it seems silly. You want the pipe to go to the ends, right? I mean, that's just kind of like a logical thing. Everybody's like, well, no, I want the pipe to go from here to here, from 2 spots. Anything you're modeling, there's 2 reasons why it's nice to take that 3 minutes and make those 2 points that are offset in as a variable. One, the thing I'm about to do right now, you want to be able to see the point easy and grab it without having the object in the way of it. You have the pipe go to the end, it covers, and you can't grab that point again. But the second one is almost everything you model is going to have some hardware, and actually the pipe's going to end here. And so, but you want the logic, this is what we're going to talk about, the structural logic will be coming back to whatever it's bearing on. So the idea that this point is the logic for the model that they're all hosting together, yet the pipe model is going to start from there. So that idea that there is an offset to that in an actual model, in reality, is relevant. You know, when we have 2 pieces of wood meeting each other, the structural integrity of the beam and let's say a truss, you know, you have truss members, there's a thickness to that 2x4. The structural line is a center line here and a center line here and a center line there. Those points are what's important, even though the wood's not going all the way to there, right? So just that idea that the structural line is different than the object, right? So I'm going to leave that at 2 feet right now. We can change it later. Pipe diameter, let's do like 2 inches. Okay. Sometimes I'm even more specific with that cable. I might even say like truss cable. So I'm going to be kind of weird, and I'm going from, so I just went from the top one. And so I'm going to grab kind of the same one down here, but I'm going to go in the opposite direction over here because spokes actually crisscross each other. I did this several times this morning and I kept screwing up. And what I was doing is I was going from an opposite one over here and then selecting that same point here. But this point right now is not the divided line point. It's the end of the adaptive pipe. This is weird. Every one of these things, there's this reference line that's a circle. We then put a skin of a divided line over it. I then put this pipe in, which then is covering that point. So when I go to attach something else, it's not going to the divided line point. It's going to that point of this pipe. There's layers to it, right? So a way of just kind of getting, so just go, sometimes it'll look right and then it doesn't work correctly. You'll see why. This one, because I went from an adaptive point, or divided line point, divided line point, divided line point, divided line point, I know that they're all going to the correct layer of information. Okay. So I can just grab one of these, the repeat and divide, and we start to have a spoke going. I say, wow, I want a lot more spokes. Okay. Making sure that everything is still working. Okay. Let's do diameter, 20 feet. And so this is what's interesting is this is just logic, right? So let's take this same idea. And what happens if I take the diameter of the ring to 2 feet and the hub diameter to 12 feet? Just reversing those, right? Because it's just logic. It's just those things going to those points. So they're all variables. I can change this. We can actually have it fluctuate and move. We get ruled surfaces very quickly, right? And we really just use that one pipe object. Okay. So I'll do that. All right, so now we got this. What can we do with it? I'll save it. I usually have oh, it's not pinned in here anymore. I usually have my PMD. So in my library, I put, so all my stuff, Plugin Made Designs, I put PMD on everything, so that's why I know I made it. It's like all of my stuff thrown in here. I put it in the folder with all the other ones at the top. That way I could get to them easy and know where it is. Tutorials, let's say Mushroom Cloud. All right. Now, this idea that it's generic model world, we can go back and do more of this. You might want to do a lot more things to this model. But what I like to do is just, when you're first working through something, this is where like you made some design decisions. You're early in a project. You sketched out some design decisions. You don't know what those dimensions are, but you're making sure you kind of put in the parameters for where you want to have changes. Now we're going to throw something together because it's the first week of studio and you just want to see something to present an idea. It's not about it being perfect. And you want to be able to delete it later or not care. And so this is where, let's say, file, new conceptual mass. This is that other world. I hate that it makes you do that. It's so dumb. I don't get it. This is kind of just the generic modeling world. So here, I could do something like, I'm going to do a weird line here. I'm going to divide that. Because there's only one of these, I'm not going to make it a parameter. I'm just making it divided. I'm going to go here and load this into 4. And I can put it right on that. Oh, wait, I need the other point, right? Because this is a 2-point adaptive. I had 2 points for this thing, right? I've got 1 point to set it, but I've got the other points over here. So I actually need a second point to put this in. And I'm going to, right now, just put a point right here on the ground. I'm going to tell it to be always seen, just like we did that other one, just so that way I can see that it's a little different. It's controlling one. I'm also just going to move it up a bit. Okay, just so that it's a little off that plane, right? Just for sake of being interesting, I'm gonna move this one down a little bit, maybe even move this one up a little bit. All right. Now, Mushroom Cloud was already in. That's how you go back and find it. Like when you first bring it in, it drops it in. After you got to go find where it is. Bring in my Mushroom Cloud. And now I can grab this point and that point. Okay, now this is interesting. We're gonna look at this compared to, I can grab this object. What's happening here, right? It's connecting to this and it's shooting up, but it's not going vertical, right? And then, but we can tell there's like a 90-degree, you can see that how that, where the projection's coming from is perpendicular, right? So this can be kind of interesting. We're gonna do it 2 ways. I can still do the repeat. This is where zoom kills it. So these are all shooting off those points, but somehow going perpendicular to this. But that's not what I wanted, right? We wanted to go vertical. Right now, these are being controlled. I touched on this. It says instance XYZ. So whatever it's being put on, it's reading that moment of orientation, right? But I want to tell it, well, I want this always to be global XYZ, no matter what. So no matter where I put it, it's always vertical is always vertical. I'm going to do the same thing with this one, say global XYZ. Sometimes it's global XY. We'll have to see what's happening. Now, it shouldn't change anything here because it happens. That's how it's oriented, right? But now all of a sudden, that line that's up there, which happened to be straight because of the way the point is sitting here, it went at an angle when we dropped it on that line, right? So now if I load this into it, again, override existing and its parameter settings, Now, this could be one where there are lots of ways of playing with this. If we want to put a column in there, so there's something, is it hanging? Do you have a crazy roof structure? Do you have a crazy roof structure, but you want a whole bunch of lights hanging perfectly in a line? This is amazing. You got a crazy thing, you want a whole bunch of perfect pendants right at a height. It's the exact opposite of this, right? We can make some structure. We could drop a whole things down. Right? You want to float desks from a ceiling right at a height. Super easy way to control it. That was one way. Let's do that same tool. I'm going to leave that one there, but instead I'm going to do reference line, SW, grab this one. Take them out of the plane a little bit. You see, I do this all the time just as a way of seeing something. Grab both. Divide surface. Let's take it down a notch a bit, 8 and 6. And now, once I've divided that surface, I want to place it on those points. So I'm doing nodes. I'm turning those nodes on. This is in all of those things, right? So now I'm getting every one of those individual points. Well, now all of a sudden, I've got points. 1 point, 2nd point. Raise this up a little bit. We might be getting close to the 100-foot though, because my scale is pretty big here. I can grab that array. Could have bumped it down a little bit for this, but whatever. Okay. Now you're like, okay, but that's boring. They're all level. What happens if I want some at different heights? Well, I could just drop another point here, make it visible. We could even like tab in. I'm going to tab this one right here. Grab you. I can delete that one. I'm going to bring this one in. Grab there. Grab here. And now I've got a whole bunch set to one point, and I could maybe have a whole bunch set to another point. You can start to terrace. There's ways of doing that as a sliding gradient. I mean, those are all this kind of layering of how are we controlling the things, okay? So what was important here is we really just use that, nothing more than that height. Now, at some point, we can bring in, we can start to control the surfaces. That could be, I could bring that box in. We're almost done with class. So, if, you know, the idea of this also being topography, we could grab that. Let's say I'm going to load in, load family. I have that box. That's real work. So I named them. So I named these all like, so these are pattern based PBs, 4 point, 2 point. So I can figure them, generic models, pattern based, space frame, floating level box. So this was that one that was along the same ideas. What we did there. Yeah, see, I named it cable. The cable is named the same, so that it's getting mad at that. I'm going to calm down before I load it in. It might change all the cables of these, because if I had the, this is where naming them specific. So when I renamed it cable, I should have said cloud cable or truss cable. I'm going to calm this down first and let it in on. We're going to put that at 4 and 4. Just a, Okay, now I'm going to grab this and I can say, I want you to be my. And this might be something where I've done a whole bunch of landscaping, but there's like, let's say these are canopies. I'm gonna have different size canopies. These were ones where I was making terraces. I might still come back through, drop this into a real project. Well, this is one where I did a space frame. This wasn't the simple box. That's why it's so weird. These were panels with space frames. So like bleachers, actually, crazy bleachers. We can get it to where you walk up. Oh, and also the idea of the type. If I go now here, I made most of those things types, right? So I could say duplicate. I'm going to say big boy, diameter 40 feet, hub 3 feet, hub down 5 minus 5 feet. Let's say 5 feet. Okay. Now you're like, oh, nothing changed. Well, because none of them are that one, right? All of them are still the first one. But I'm going to grab this big one right here. If I tab in, I should be able to just grab that one. Grab that one. I could come over. It's mushroom cloud, but I also have the other type. So variation, right? It took a while to make that one, but if you know kind of what you want to play with, this is where I just can't tell you how, like, you do this in the first 3 weeks of class, start just because you're working on an idea, you're pushing out the idea. By the end of the semester, we can be coming back in, and each one of these becomes more and more intense. You start to solve bigger problems, you adjust them, you change them, but you're able to kind of see them in action, right? And make decisions. So, but a ridiculous amount of tiptoeing to get through the beginning of it. It's hard. I'll tell you right now, there's one thing learning all the commands, watching the tutorials. You'll kind of, that's what I want you to get. Like, what is a instance versus type? What is a generic model versus generic model adaptive? What is pattern based? Okay. These are all things that you have to kind of appreciate by the end of this semester. Sooner the better, because it helps you model the things that we're going to do for this class so we can talk about the structures of it. When we get to the end where you're doing the independent study, the ability to decipher, to have a design and figure out what path you want to use to model it, that's hard. Okay, like by the end of this semester, I'll be helping you based on the design that you want, figure out what path you might take in Revit to do it. That takes a long time because there's different ways to model it. And it really comes down to like, what do you want to be a variable? And so a lot of times I'll tell you like, you want it this way. And it's like, okay, but what do you want to change about it? Is it just fixed and that's it? Because we could just make a generic model that's fixed and you can just throw it down. But if you want to spend a little time, is it something that you can adjust and change? And so those are different starting points. It's literally a different file that you're opening. So that's the tough thing. Don't expect to get there soon. Don't really expect that you're going to be modeling crazy stuff in Revit this semester if it's brand new to you. It takes a while to decipher it. Okay. You're also not modeling the whole project. So a lot of this, I might do a lot of stuff where it's mostly generic stuff in Revit, normal Revit, and then you're only bringing in some key elements this way, right? Because now what I would do here is I could just open up a normal project and drop this in. So I'd say, let's say file, new project. We got 5 minutes. I've got my own templates because I don't like this stuff. I wish it went to it, but it doesn't. I got to save it in that other area. Go back to this one, load it into project. And this would be one path. This would be one way to do this is you know your constraints, you know your sizes, you've modeled it in the conceptual mass world, and then you just drop it into the project. We'll get a little later where everything we do in conceptual mass you could do in the real Revit world, but you got to do it in the in-place mass editor. It's got to be in a floor plan level. So that idea that we could have, let's say, made those surfaces and divided those lines and placed all that stuff in the real Revit world too. You just got to do it through the window of in-place mass, which we'll talk about later. That's a certain thing within Revit. And that's really what the conceptual mass world is. It's just that on its own. There's a program called Sorry. This takes a little bit. I got to redrop it in, I think. But anyways, we will start to pick a bunch of like one more crazy day like this, of random stuff, and then one where I'll ask you to model something very simple so that we can work on export to Illustrator and talk about those commands. Revit aside, damn it, get fast at Illustrator. Okay, you don't understand what that saves you in time and sophistication of what you're communicating to somebody. You got to get better at that. Or it's amazing the difference in what happens when you're good at that. You win, you know. I mean, you could also say like Dylan's model was nothing, but his ability to do Illustrator well is what won him a national award last semester. It was just strong Illustrator work. It's not V-Ray. Nobody cares about renderings. Believe me, that is so dated. Like V-Ray, no one cares about your renderings. Everybody can do it better than you. It's not a skill set. It doesn't matter. We could pay anybody to do a rendering. Okay. And so it's what you're communicating, not how well it's rendered. So just get over that. So, all right. Yeah.